Hello everyone, this one is our first session on a Fourier series. So Fourier series, in the first session, you will learn about the interval minus L to L. Okay, so the first thing that you should remember, the Fourier series for the periodic function fx is given by this formula. You should remember the formula is f of x is equal to a0 by 2 plus summation an cos n pi x upon L plus bn sin n pi x upon L. So this one is a Fourier series for the interval minus L to L now. For the interval minus L to L, A0 is given by 1 by L integration minus L to L fx dx. This is the first Fourier coefficient A0. Then An is 1 by L integration minus L to L fx cos n pi x upon L, and Bn is 1 by L integration minus L to L fx sin n pi x upon L dx. So this A0, A and B and these three formulas along with the Fourier series formula, that is mainly the important one. Everywhere you are going to use these formulas only. So our aim is to get the values of these coefficient A0, A and Bn and replace in the equation number 1 here. Okay, so that is only the thing that we have to do in the Fourier series. But as the interval is a minus L to L, and suppose that fx, okay, that fx is say odd function, fx is odd, then what happens, you will observe the integration is minus L to L. In the integral minus L to L, whenever integrand is odd, the value of integral is a 0. So what happens, this a0 and an both becomes a 0 because the fx is odd and the interval is minus L to L. The more important thing, minus L to L. Only we have to calculate a Bm. We have to calculate a Bm. Similarly, if our fx is even and the interval is a minus L to L, then 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 Bn is only 0. Bn is only 0 because that integrand becomes odd there and that coefficient becomes a 0. And how to identify even and odd? There are 2-3 ways to identify that. You already see the previous video of the prerequisite only. One of the way is to observe the power of function. Second way, the graph. And the third way, yes, obviously f of minus x is equal to fx, then it is even. F of minus x is equal to minus of fx, it is odd. Okay, so that about the prerequisite and these things that you should know. Come to the example now. The first question for find the Fourier series or the Fourier expansion of 1 by 2 pi minus x, and the interval is given minus pi to pi. So remember, in a solution, always you start with comparing with a general interval, as minus L to L is our general interval, and in this case we are given minus pi to pi. Step number 1, you should write the value of L. Here L is a pi. L is pi. So that about the step 1. And then you start with the formula. The formula, always make a habit of writing this formula. A0 is 1 by L integration minus L to L fx dx. Next step, just we replace the value of fx as a 1 by 2 pi minus x. Okay, now this pi minus x is neither even nor odd, because obviously that x is odd function, but pi is an even function, constant function is even. So whenever both even and odd terms are appear, we not apply that results like 0 or 2 times 0 to L. Okay, so let me integrate it one by one. 1 by 2 is a constant outside, so 1 by 2 pi is outside. Integral of pi is a pi x. Integral of x is x square by 2. Now just do step by step. If you are not getting directly the answer as pi, so 1 by 2 pi as it is. When we put upper limit, there, you will observe pi into pi become pi square minus pi square by 2. This is for upper limit, minus now lower limit. Let me replace x by minus pi. Minus pi into pi is a minus pi square, and here this is a minus pi square is a plus pi square. So this is minus pi square by 2. You will observe the two of the terms gets cancelled. Say this is minus pi square by 2 with a minus minus plus pi square by 2 gets cancelled, and we left with this 1 upon 2 pi, 1 upon 2 pi, pi square plus pi square is a 2 pi square. And you'll observe again this 2 gets cancelled, one of the pi gets cancelled, this 2 gets cancelled, one of the pi gets cancelled, and we're left with just pi. The pi is the value of a0. Okay. So this is the way you should calculate a0 first. Now come to the formula for an. Already I told, make a habit of writing the general formula first. The general formula is here. What is that formula? 1 upon L integration minus L to L fx cos n pi x upon L dx. My mistake. Here it should be, this term should be cos of n pi x upon L dx. Okay, so that should be the term there. Now we are replacing the value of L. See, when you replace L by pi, in this case L is a pi, so it is 1 upon pi integration minus pi to pi, fx is 1 by 2 pi minus x. This L and pi gets cancelled because L is pi, so it becomes cos nx only. Now it is correct. Okay, so this is the correct step. So always start with the general formula and then you replace the value of L. L is a pi. And what happens now? Next step, we are going to use the most important thing is a generalized by part. Now remember this 1 by 2 and pi, this 1 by 2 pi is outside. Let us take this this first pi minus x as a u, and this one is a v, and we have to apply generalized by part. If you're not able to write it directly, what you have to do is do some rough work there. What we done, we taken u as a pi minus x. And what about v? V is a cos nx. So write u dash. U dash, derivative of pi minus x is a minus 1. Write u double dash. U double dash is a 0, right? The derivatives till you get a 0. So we got 0. Now calculate equal number of integrations. Say v1, integration of cos is, remember integration of cos is plus, so sin nx upon n. v2, now v2 is integration of v1, so integration of sin nx upon n becomes minus cos nx upon n square. That's one. Now we have to write a formula here. We have to just replace these values. So how we write it? We multiply u with a v1, u dash with a v2, and that's one. Okay, u triple dash with v3, but actually u double dash is 0 and all others are 0, so no need. So here is these terms, u v1 minus u dash v2. You will observe the same terms written in the bracket. This first term, this one is a u, this one is a u dash, and the remaining is a v1 and v2. Okay, and that's one. So we are replacing the limits now from minus pi to plus pi. So the next step, if you're not again getting this direct answer, you do step by step. The next step is 1 by 2 pi. We are replacing pi there. So pi minus pi, first term pi minus pi is a 0. This is a 0. Okay. Next, remember, okay, the most important rule that I forgot it again, but obviously all you know that the terms of sign always goes to the 0. So this term go to the 0. No need to calculate it, because why this is 0? When you replace x by pi or minus pi, it becomes sin n pi. Sin n pi is a 0. Sin 0 is a 0. Sin 2n pi is a 0. So that term is a 0. No need to calculate it. We are coming to this term actually. So second term where we are replacing x by pi. So this, how many times minus? 1, 2, 3. 3 times minus sign. So that is a minus there. Minus cos n pi. Okay, I will write as it is otherwise. You will next step, because this is a habit. You should keep it. Those who are not able to do it directly, do step by step. Cos n pi upon n square. We replaced x by pi only. Now we are replacing lower limit, which is the lower limit have the minus sign. So this minus is there. Now bracket, lower limit minus sign there. And how many minus are there? 1, 2, 3. 1, 2, 3. So that minus minus I will take as a plus. Plus, and this is a cos of n pi, that will become minus n pi now. Cos of minus n pi upon n square. So this way, just I replace x by pi and x by minus pi. What happened here? 1 by 2 pi as it is, this minus cos n pi. Remember, cos of minus theta is a cos theta. So indirectly, we are getting cos n pi minus cos n pi. The first term is a minus cos n pi. Second term becomes plus cos n pi. Why plus cos n pi? Because cos of minus theta is a plus cos theta only upon n square. But these are the same term, gets cancelled each other. And what we got? The answer is a 0 there. So this is the value of an. An becomes a 0 there. Okay, so this way you can do it step by step. Whatever extra steps I'm writing, these steps also you can write it, provided you are not getting it directly. So this way the generalized by part works, and we get the answer there. Exactly similar calculation we have to do it for a bn now, but again in the term of a bn, I will tell you the formula starts with the formula starts with 1 by L integration minus L to L 1 by 2 pi minus x sine, this is actually a sine n pi x upon L, n pi x upon L dx. So this is the general formula where we replace L by pi and we get this as the answer. This is the answer there. Okay, so I can okay, no issue. So here also we have to apply the generalized by part, and exactly similar thing that we have to do it here. So let me take this pi minus x as a u and sine n x as a v. Okay, and exactly similar derivatives we require. U is a pi minus x. Remember these same derivatives that you use for an you require again here. U dash, u double dash. You will observe these are same derivatives here. Okay, so same derivatives what we used. Now what is v here? V is sine nx. V is a sine nx. So v1 is integration of sine nx minus cos nx upon n. Remember, for sine is a minus sign there. V2 integral of minus cos become minus sine. Again the same thing that we have to do it. We have to cross multiply. U is multiplied with v1, u dash is multiplied with v2, and we are going to write the general term. That general term will look like this. This is a u v1. Here you can put the bracket also, minus u dash v2. Just the terms are replaced, nothing new done there. So let me replace see the thing that we already discussed, that always the term of sine goes to the 0. So no need to do the calculation for this term. This term is always 0 because it is a sine. Sine n pi is a 0 there. Just we have to do the calculation for the first term, and in the first term if we do the calculation 1 by 1, 1 by 2 pi is a constant outside as it is. We are replacing x by pi, so pi minus pi 0, is it? For upper limit it is a 0 because x is a pi. So 0 into whatever that is a 0, we not write other terms. Lower limit of the minus sign. Now we are replacing x by minus pi. See, this is a pi, this is a pi, and lower limit is already we are replacing x by minus pi. Minus minus is a plus pi. Pi plus pi. Pi plus pi, and then this is a minus cos n pi. I am writing into minus cos n pi divided by n. So this is the terms that we left. You will observe this 1 by 2 pi, and remember this is a minus sign and this is minus sign. This minus minus plus, and this pi plus pi is a 2 pi. What is a cos n pi? Cos n pi is a minus 1 raised to n upon n. So these two terms gets cancelled and we're left with this only minus 1 raised to n upon n. That is the value for bn. Now, once we get the values of A0, AN, BN, near about 80% or 90% of the example we completed, don't forget to write the Fourier series now. Thus, the Fourier series, that is fx A0 by 2 plus summation AN cos n pi x upon L plus BN sin n pi x upon L will become, here we have to replace the value of L first. L is a pi, so what happens? This pi gets cancelled, and we left with a0 by 2 plus summation an cos nx plus bn sin nx. This is particular, and in this we replace a0, an, and bn. Remember, this an we got as a 0. An we got as a 0. Because of that, we left with a0 as say the value of a0, let me check. The value of a0, we got it as pi only, so it is a pi by 2. So here is a pi by 2, and here is the value of a bn sin nx, and this is the required Fourier series for the given function. This is the answer. This is the required answer. Okay, so this is the way you can get the Fourier series of the interval minus L to L type. This is just a first example. Now similar questions here. So one more example is taken. Now second example, if I show you here, we are given x square as a function where the interval is similar minus pi to pi. So the formula starts with 1 by L minus L to L. Replace the value of L. Integral of x square is x cubed by 3. And when we put upper limit and the simplification, you will observe 2 by pi is there. And you're left with there as a pi cubed by 3. Pi cubed by 3. And the lower limit, if you replace x by 0, is a 0. So one of the pi gets cancelled and you get the value of a0 as 2 pi square by 3. 2 pi square by 3. So that is a0. It is just integral of x square. But when you start with the an, remember everywhere I made one silly mistake here. Cos in the beginning, the formula is cos of n pi x upon L. N pi x upon L. And then we replace the value of L, L by pi, L by pi. Then this step comes. Okay, then this steps comes because we replace L by pi and then pi gets cancelled and cos nx will left only. Now, the most important thing here, because the interval is a minus L to L, interval is minus L to L, and fx is a even. See, fx is a even function, fx is even, cos nx is also even. So multiplication of two even function is again a even. Remember, just like x square is even function, and if you multiply some another even function, say x raised to 4, we get x raised to 6. So remember, this even function into even function is an even function only. So here that fx is even, cos is even, hence this entire integral is even. So there is one property that is used. It is not compulsory to use, but here integral minus pi to pi, this integration minus pi to pi become 2 times 0 to pi, 2 times 0 to pi there. And this is a 2 by pi, integral 0 to pi x square cos nx is left now. Because of even function, it become 2 times. Now the exactly same thing we have to do it. This one is our u, x square is u, cos nx as a v, and we'll apply the generalized by part. So to get a generalized by part, I will write the terms here. So you will observe u is taken as, okay, I will do like this. U is x square. U is x square. So u dash is a 2x, u double dash is 2, u triple dash is 0. Now what is v? V is a cos nx. V is a cos nx. What will be v1 then? Integral of cos nx sin nx upon n. What about v2? Integral of sin nx is a minus cos nx upon n square. v3, integral of minus cos nx is a minus sin nx upon n cube, this way. This is the integral. How we will multiply? We multiply u with a v1, u dash with a v2, u double dash with a v3. So this way we multiply it. So you will observe the formula. The formula we get u v1 minus u dash v2 plus u double dash v3. So these values we replaced here in the bracket. You will observe. Okay, and after this, if you are still not able to get a direct answer, this is the direct answer. If you are not able to get this answer, what you can do it, you replace and write a step by step there. So what about the value we get? An is 2 by pi. We are replacing x by pi there. So it is a pi square. The first term is a pi square. Sine. Okay, my mistake again. Don't write the terms of sine. At least you should get this term. Whenever the terms of sine are there, they goes to the 0. No need to do that calculation only. So these terms are 0. Is it okay? Is that okay? And now we have to replace only in the middle term. We replace x by pi. So minus 2 pi minus cos n pi upon n square. So this is for upper limit. Now we replace lower limit x by 0. If we replace x by 0, lower limit minus 0. No need to write it. That's one. Now you'll observe this minus and this minus become plus there. Okay. So and that pi also gets cancelled. So this we left with 2 into 2 is a 4, minus minus plus, cos n pi is a minus 1 raised to n and upon n square. So that about the required answer. This is the value of an only. Okay, so this is the way we get an. Exactly same calculation, exactly similar calculation. We have to do it for the sin nx is not there, sin n pi x upon l, sin of n pi x upon l. So that is there. But here there is no need of a by parts. Now we should use a smart work. Fx is even, sine is odd, multiplication of even into odd is odd there. For example, x square is even, x cube is odd, and if you multiply these two, there is addition of the indices x raised to 5. So even into odd function is always odd, and in this case, what is there? See, fx is even, this fx is even, sine is odd, even into odd is odd, and range is minus L to L. So the answer is always 0. No need to calculate, no need to apply generalized by part. Even though you apply generalized by part, your answer will come 0 only. So Bn is 0 directly. Just say fx is a even function, hence Bn is 0. That also you can write it. Fx is even, so Bn. And lastly, don't forget to substitute the values of a0, an, and bn in the final answer, and you get a Fourier series. So this is the answer. This is the required answer there that we require. Okay. So that is the Fourier series for x square on the interval minus pi to pi there. Now come to the third example. The third example, now see the difference. The difference is the function is a different on the different interval. It is a minus pi on the interval minus pi to 0, and it is x on the interval 0 to pi. So complete interval is actually minus pi to pi only. On the interval minus pi to pi, the function is a given, but we have on minus pi to 0 it is just minus pi, and on 0 to pi it is x there. So we can calculate these. Now whenever the function is like this, you can better you calculate a0, an, bn one by one only. Okay, don't do a silly mistakes in a calculation only the integral we have to split up into the two parts. If you start with the general formula, the general formula is a0 is 1 by l integral minus l to l fx dx. Next step, you can write it as 1 by pi integration minus pi to pi fx dx. But now this integral minus pi to pi, we have to split up as minus pi to this 1 by pi as it is, and we can split up this integral is a minus pi to 0 fx dx plus integral 0 to pi fx dx. This we can do it. The reason is we do not have the same function from minus pi to pi completely. We have different function. On minus pi to 0, what is fx? Fx is minus pi on this interval, minus pi to 0. It is just minus pi. From 0 to pi, what is fx? Fx is x only. So that we are replacing here. Now we have to do the integration only. So what is the integral of, let I write here that terms directly. The answer is written. So 1 by pi will be as it is. Integral of minus pi is a minus pi x, and the limits are minus pi to 0. And integral of x is x square by 2, and the limit is 0 to pi. So we are putting upper limit. When you put upper limit here, this is 0, but lower limit have the minus sign. That minus, this minus sign again minus pi. So 3 times minus sign will come. So 1 by pi. I will write the last step of this on the upper side there. So which is a 1 by pi. 1 by pi. We are putting, see, upper limit is 0, lower limit minus sign 3 so it is a minus pi square. Minus pi square is coming for lower limit here, plus here the bracket is closed, and when you replace upper limit here, plus pi square by 2. This is the upper limit, pi square. Lower limit is 0. So minus pi square plus pi square by 2. So you will observe it is a minus pi square by 2. So 1 by pi in bracket minus pi square by 2. And you will get the answer as a minus pi by 2 then. One of the pi get cancelled. Remember, whatever the steps I'm writing, you can write it step by step in the notebook. Then definitely you will understand it. Okay. So because many steps are dropped here and direct answers are written, you have to do it step by step. Now, what about how to get an and bn? Exactly similar way. What is done here? First, general formula is take a general formula for an. Like I will just write a formula of an here. Okay, an is 1 by L integration minus L to L fx cos of n pi x upon L dx. This formula we have to split up as 1 by pi. Not only that, I will take it as a minus pi to 0 fx cos nx dx. Why cos nx? Because L is pi, plus 0 to pi fx cos nx dx. So this way you have to split up first. Split up. And now whatever the fx we have on the interval minus pi to 0, that is we replaced here, because minus pi to 0 fx is minus pi only, and for 0 to pi fx is x. And here again we have to do the same thing. We take this pi is a constant here, direct integration, but second case we use generalized by part, u and v. Use the generalized by part, then put upper limit, lower limit. Here direct integration. What is integral of cos nx? You have to take integral of cos sin nx upon n. But sin nx upon n, the term sin comes, so this value, the value of this integral, will go to the 0. Okay, because you will get sin. So do step by step. Don't do like directly this way. Write integral of cos nx as a sin nx upon n, and then it is a 0. Here apply generalized by part and do the step by step, and you should come to the same answer here. Exactly similar calculation, do it for a bn, and you should cross check whether you are getting these answers. Once you get this answer, see the 2 3 values we are using. Sin 0 is a 0, sin n pi is a 0, cos 0 is a 0, cos n pi is a minus 1 raised to n. So these are the values actually we are using. If we replace these values in the Fourier series, this will become the answer. This is the answer of the Fourier series on the interval minus L to L of that splitted function. Okay. Take here a last example now. The example 4, where we have fx is 1 minus x square, and the interval is now not minus pi to pi, it is a minus 1 to 1. Okay, so this is 1 minus x square, and you should know that 1 minus x square is an even function, because the interval is minus 1 to 1. We can use that properties. See, here you can check with f of minus x is equal to plus fx, hence it is a even, or constant function is even, x square is even, so completely it is even function. So first thing, identify it is even function. Then start with the formula. The formula for a0, the formula for calculation of a0, you already know. It is 1 by L integral minus L to L fx dx. But as fx is even, we can write it as a 2 times 0 to L. 2 times 0 to L fx dx. Whenever it is even function, it becomes 2 times when integrand is even, and when it is odd, the value is a 0 there. So LQ replace the value of L as a 1. So 1 by 1 minus 1 to 1 fx dx, it become 2 times 0 to 1. You will observe the same property applied here. And now this integration is done, and you got a 4 by 3 as answer. Okay, so 1 minus 1 by 3. So it is a 2 by 3 into 2 is a 4 by 3. So that about a0. Come to the value of an. So exactly same thing. Now don't forget, this is the silly mistake that many of you do it, where general formula is 1 by L integral minus L to L fx cos n pi x upon L dx, and in this case L is a 1, so we left with cos n pi x and not cos nx. Cos nx will be the case when L is a pi. In this case L is not a pi, L is 1, so cos n pi x will left. So the same property is used, that as fx is even, cos is even, this integrand is even, so it become 2 times 0 to 1, 2 times 0 to 1, because this is the even function. Here we are going to apply the same thing, u and v, generalized by part. U is 1 minus x square, v is cos n pi x. You will observe, you are writing this as a u, then you have v1 minus u dash. This bracket is a v2 plus this bracket is u double dash, and last bracket is a v3, where the limits are 0 to pi. This is a 0 to, sorry, 0 to 1. 0 to 1 is the limit of the bracket. Just, if you're not getting this answer directly, as I told, first check which terms goes to the 0. The terms of signs are always 0. No need to do any calculation for them. But the middle term preserves, where we replace x by 1. So if we replace x by 1, the an will become, this 2 is outside. We're replacing x by, how many minus? 1, 2, 3. 3 minus means the result is a minus 2. Then cos x is 1, so cos n pi we left, cos n pi upon n square pi square. You will observe cos n pi is a minus 1 raised to n. So this 2 into 2 is a minus 4. Minus 4 cos n pi is a minus 1 raised to n upon n square pi square, and that is the value of an. But remember, this minus sign is just raised here and it written minus 1 raised to n plus 1. Both are same. This is the same answer of this one. So both, you can keep any one of that, any one of this. So that's the an. And the best part happened here now, as fx is a even and the interval is minus L to L type. So value of a bn is 0, since that fx is an even function and fx into sine is odd. Multiplication of these two becomes odd and the bn becomes a 0. And the replacement in the final Fourier series, you will get the required answer. So that about the case minus L to L mainly. Okay, I hope you understood the first case, minus L to L. We'll move to the another type of examples in the next session. Mainly this session, I focused only on algebraic function, how to handle algebraic function. It is just by generalized by parts and the integral of x raised to n, derivative of x raised to n. So these 2-3 formulae you require, and exactly same thing you'll observe sine 0, sin n pi, they are 0, but cos 0 is 0, cos n pi is minus 1 raised to n. So these are the formulas that mainly we use in this session. Okay, and these are the most important, this is one of the most important type of the Fourier series there. Okay, so you should do it on the paper, try it on the paper first, just note down the example, complete your calculation and cross check with the answers there. Okay, so thank you.